All right, we are working on applications of special rate triangles. We're going to be using the 45, 45, 90 and 30, 60, 90 that we had learned the other day. All right, but before we get into that, let's do some vocabulary. Some of this you may have heard of, some may be brand new. All right, so the first word we're going to talk about is the altitude of a triangle. All right, and the altitude is a line segment that's drawn from a vertex of a triangle, and the segment is perpendicular to the base of the triangle. Okay, so once again, it is a line segment that is drawn from a vertex meaning your corner, okay, or your angles. And the segment is perpendicular. Remember, perpendicular means it forms a 90-degree angle, okay, and it's perpendicular to the base. So let's go ahead and let's draw a triangle in our box. Okay, right now it doesn't matter to me, angle, measures, side lengths, whatever. Okay, it's a triangle, it's a three-sided figure. Okay, so the altitude is going to be drawn from a vertex. So I actually have three different altitudes. I'll go ahead and show you all of them. My first altitude I can draw right here. So it's a line that goes straight down to the base, and it forms a 90-degree angle. Okay, another one I could draw from this vertex over here. So I'm going to draw it to this base, and that one forms a 90-degree angle. Okay, and then the third one I can draw from this vertex over to this base, and that forms a 90-degree angle. You know, say I'll cross each other. So there's three different altitudes. It's drawn from a vertex or a corner, and it goes straight down, and it forms a 90-degree angle with the base of the triangle that it hits. Pretty picture. Okay, our next word. The altitude of an isosceles triangle. All right, take a second and think to yourself, what is an isosceles triangle? If you said an isosceles triangle has two sides that are congruent and two base angles that are congruent, then you are correct. All right, so the altitude of an isosceles triangle does two things. The altitude bisects the vertex angle. Bisects means it cuts in half. It also bisects the base of the isosceles triangle. So it cuts the base in half, making two equal line segments. All right, so let's go ahead and draw an isosceles triangle. Okay, before we do anything, I know that since it's isosceles, these two sides are congruent, and then these two angles are congruent. Okay, that has nothing to do with the altitude. That's just because it's an isosceles triangle. All right, so let's go ahead and draw the altitude. If it hits the vertex angle, meaning it's coming from up here. Okay, it's not coming from one of the bases. So if it's coming from the vertex angle, it's going straight down. First of all, we form a 90 here. But here's else what it does. It means that this little piece is congruent to this piece. So I cut this whole line segment in half. I also know that this angle is congruent to this angle. Okay, so if that whole thing was 60 degrees, then each of these little parts would be 30. Okay, so just something to think about. So we're going to use these concepts today as we try to find altitude lengths and side lengths of triangles. The last new word will be the diagonal of a polygon. A line segment drawn from one vertex to another non-consecutive vertex. All right, polygon just means many-sided figure, so we could do a triangle, we could do a square, a rectangle, a rhombus, we could draw a pentagon, whatever. Okay, many-sided figure. And it's drawn from one vertex to another non-consecutive. Non-consecutive means not directly next to. Okay, so let's go ahead, let's just draw a rectangle. Okay, just put in my 90-degree symbols there because I know it's a rectangle. All right, so if I'm going to go ahead and I'm going to draw, hold on, color change. I'm going to draw in a diagonal from here to here. Okay, that's my diagonal. It's non-consecutive. So I couldn't draw from this side up to here because those are next to each other, from this side to that side, because that would form the side of the polygon. All right, so your diagonal goes across. I actually have two in this example. This one is also diagonal. Okay. All right, so let's go ahead and actually do some problems, keeping in mind these three vocab words. All right, so what we're going to do is we're going to solve some problems, and the following examples are problems are applications of the special rate triangle, so that 45, 45, 90, 30, 60, 90. The best way to solve them is to do the following. First thing we're going to do is draw or label the diagram with any side lengths or any angle measures that we know. We're going to draw on any relevant segments, any altitudes, diagonals, anything that's going to help us. And I'm going to talk you through this. Then we're going to find the angles involved. Okay, so we know if it's a 45, 45, 90 or a 30, 60, 90. And then we're going to find the answer. Let's take a look at what this is. Okay. So example number 1, what is the length of an altitude of an equilateral triangle whose side length is 2 radical 2? So we're going to find the length of that line down the middle. The first thing we want to do is label our diagram with any information we can. Okay, because it says it's equilateral, guys, that means that all sides are congruent. So all the sides are 2 radical 2. So I'm just going to go up here and I'm just going to label my sides. I may or may not use one of the sides, and that's okay, but why not provide myself with as much information as possible so that I can go ahead and use what I need to. All right, now equilateral triangle, since all sides are congruent, all angles are congruent. So if I do 180 divided by 3, I get 60. Okay, so all the angles are 60 degrees. Okay, because 60 plus 60 plus 60 is 180. All right, good. Now the problem says, what is the length of an altitude? So the altitude, I'm just going to draw. I could technically draw from any vertex, but let's keep it simple and go from the top. I'm going to draw down here. I'm going to make that 90 degrees. Okay, I'm going to make it 90. Okay. Now, what else? So looking at it, I've got information. I'm trying to find the altitude, so we're going to go ahead and label that X, because that's what we're finding. It's always important to note out what you're finding. Other things I can point out, since this whole big thing up here is 60, I know that the smaller pieces are 30, okay, because the altitude can cut that in half, because technically we are dealing with an isosceles, so keep that in mind. An equilateral triangle is also isosceles, since at least 2 of the sides are equal. So now I'm going to decide. Everything is labeled. I need to find X. Is this a 45, 45, 90? Or a 30, 60, 90. If you said 30, 60, 90, you are correct. All right, so I'm going to use this triangle right here. I'm going to outline it for you. Or we could have done it on the other side, but whatever. I'm cutting in half because now I can use my special little chart because it's a 90-degree angle. So since we said 30, 60, 90, let's go ahead and fill her in. So 30, 60, 90s. 1, square root 3, 2. That is something that you should just have memorized. So now I'm going to fill in the pieces I know. Okay, start by your X. So my X is this side. My X is directly across from the 60-degree angle. So that's going to go down here. All right, now, I also know the length across from my right angle is 2 radical 2. Guys, that's all I need. I don't need to find the other side. I could if I wanted to. But what you have to be careful of is this. This side that I drew in purple down here is only half of the entire thing. So if I'm going to fill this in on the chart, I cannot use 2 radical 2 because the 2 radical 2 represents the whole thing. I would only take half of it. Okay, so be careful when things get chopped in half or in pieces. Okay, start by using your whole parts. So if I wanted to, I could take half of 2 radical 2, which is just radical 2. But if that's too much for you, then ignore that because I don't really need it. All I need is one of my side lengths. All right, so now I'm going to go ahead and I'm going to set up my proportion. Radical 3 over x equals 2 over 2 radical 2. And I'm going to cross multiply and solve. 2 times x is 2 times x. That equals 2 radical 6, because radical 3 times radical 2 is radical 6. Now I divide both sides by 2. They cancel. Those cancel, so I have the square root of 6. So that is the answer. That is the length of my altitude, the square root of 6. All right, so I had to fill in. I made it really pretty, fill in as much information as possible, and then solve my problem. All right, guys, I'm going to pause the video, and I want you to actually try this one. As I said to my classes, just ignoring and playing through and copying down on the you tries does not help you. It says try. If you're not sure, that's when you bring your questions to class, but you don't know if you know it if you don't try. So please pause the video and try this one on your own. All right, go ahead and take a look. The answer is 14 radical 3. It's in my really pretty bubble. Okay, so I drew my diagram. They told me that the altitude is 21, so that's the line down the middle. That's not the sides of my triangle. I don't know the side lengths of my triangle, so that's why I put a big old X right there, because I don't know. All right, now, I don't know the length of this little guy, and I don't care, guys. All you need is one known and one unknown. All right, so then you just got to figure out which part of your chart to fill it in with. So the 21 was across from the 60, so that's why he went down there. And then the X was across from the 90, so that's why they went down there. If you're having trouble matching the angles and the sides, make sure you go see your teacher. So I set it up, radical 3 over 21 equals 2 over X. Cross multiplied, X times radical 3 equals 21 times 2, which is 42. Divided by radical 3, so I have 42 over radical 3. But of course, we're practicing rationalizing that denominator, getting rid of the radical underneath. So I multiply by radical 3 over radical 3, giving me this, 42 radical 3 over 3. And then you've got to check and see if you can divide the numbers, 42 and 3. I can't touch what's under the radical because it's under a radical. But 42 divided by 3, they do go evenly, giving me 14 radical 3. All right, if you need more time to look at this, pause it. I'm moving on to the next slide, but you can pause and look or rewind. All right, so the perimeter of a square is 24. What is the length of its diagonal? So draw on the diagonal because that's what we're trying to find. X, what is the length? X marks the spot. Now the directions say the perimeter is 24, so we're expecting you to have some prior knowledge. This is a square. What is true about the measures of a square? All sides are the same. There's 4 of them. So to find the length of one side, I'm just going to do 24 divided by 4. Okay, so guys, you're given information for a reason. You've got to use it. So the answers and numbers may not be right there. Do not go and write 24 on every side of that square. Actually do the math and see what you have. And here's a right angle because it's a square. Okay, now, in a square, all the sides are right angles. The diagonal cuts that angle in half. So this is a 45 and this is a 45. Okay, we also can tell then if you weren't sure because these two sides are the same. So that means the base angles are the same, meaning they're isosceles. Okay, so 45 and 45. So now set up your chart. So I've determined that it's a 45, 45, 90 triangle. So that I have the ratios of 1, 1, radical 2. Okay, the ones across from my 45 are the 6. The ones across from my 90 is the X. So I set up my proportion, 1 over 6 equals the square root of 2 over X, and I cross multiply. 1 times X is just X. 6 times radical 2 is 6 radical 2. I'm done. That's it. So it's determining 45, 45, 90 and which sides go with which angles. All right, please pause the video. Try the next one on your own. All right, and the answer is 9 radical 2, 9 square root 2. Okay, this time they told me the diagonal. I had to find the side length. So make sure you're reading those keywords and knowing what you're labeling. So my diagonal is 18, so those are both X. Okay, it's a square, so since I cut in half and those are the same size, I got 45, 45. So it is a 45, 45, 90. All right, the X's are across from my 45-degree angle. The 18 is across from the 90-degree angle. All right, so I set up the proportion, I cross-multiplied, I solved, I rationalized my denominator. All right, guys, we are done for today. Please bring questions to class. If there are questions, I have no idea what's going on, then you need to also be seeking extra help if you're not getting it, if you're not understanding by the end of class time, okay? But make sure that you're doing this and asking questions by writing them down and bringing them to class. Goodbye.